I'm going to bring Rohan, as I said, who is an expert in this domain, and for the demo part. So Rohan, I'm going to make you presenter.
Thank you so much, Atul.
Okay, so one thing, Chris is saying, okay, traffic. Okay, I think you've all answered. Let's complete on here. Yeah, over to you.
Thank you, Atul. Just quickly confirming if you can hear me okay and see my screen okay as well.
Yes, sir, your screen is visible.
Yes,
Awesome.
yes. It is.
Awesome. Thank you. Let me quickly tell you what we are going to do now. One is we are going to create a simple Python app, and we're going to run it. And then what we will do is run this app inside a container. We were listening to Atul a few minutes back. He was talking to us about how we can create a Docker file and create an image out of that and run inside the container. I'm going to show you a simple Python program. We will run that on our server, and then we will create a simple Docker file. I will run you through the few steps of what a Docker file is, what is going on, of course, at the very high level, and then we will make use of an an existing image, maybe from the Docker Hub. And I heard Atul making use of the CI/CD server Jenkins. Let's make use of the Jenkins image available on Docker Hub, deploy and run it as a container. And when I show you that, you will be surprised how easy. Maybe it takes me a minute or less than a minute if I have the image available locally to set up and run Jenkins in a container. We are going to see all of these. Let's get started. Let me create a simple Python program or application which just says maybe hello world and welcome to the training, right? And it uses your Flask framework. Let me quickly create
just for everyone's benefit, this is, we are showing demo as a Python, but it could be any language. It could be Java, it could be .NET, it could be Python, it could be PHP, whatever you're doing. Any application which is running on a normal, you containerize these days, and the way we are containerizing, we'll showing it here. Over to you.
Thank you, Atul. Let me quickly create the files needed. Bear with me for just 1 second. I'm creating a text file. I'm going to talk to you about this file. I have a sample Python program already written. In the interest of time, let me just move that from here to the folder I need to. Let me open this particular Python program and let's see what we have inside that. It's a simple Python program. I'm just making use of some colors, some HTML tags, just to show you hello world, right? I say hello world, welcome to K21 Academy is what we are showing in this simple web application what we have. Let us test this application. Right now I have this code out here, app.py. How can I run this on my server is I do Python 3 and I invoke the Flask and I run this. Now, it says, if you want to access this particular application on your local host. Let me quickly do that. Let us do localhost at port 5000, right? So right now, this application, this simple web app application, what we have just does welcome to the session, right? Which is running on my server. How can I Dockerize this? How can I make this particular application run inside the container? Of course, what we are seeing here is a simple program, right? But in real world, of course, it's going to be a complicated programs what you have there. The flow is going to be same. It doesn't matter if it's a small program or bunch of programs. The way we create our containers and images are going to remain the same. So just have a simple program out here. Let's go back and look at how we can Dockerize this. Now, to run this particular application inside the container, I have to create an image out of it. Let me cancel this out. I have to create an image. Atul was showing you a few slides a few minutes back. He spoke to you about Docker file. For our application to run as a container, we need to have an image. To build the image, we need the Docker file. Docker file is a text document that contains all of the instructions to assemble our Docker image. We tell Docker and we make use of Docker build commands to create that particular image and run them inside the container. There is a special syntax we observe to create our Docker file. Let me quickly bring out the Docker file what I have. Let me open the Docker file. Let me set the line numbers real quick. Docker file is a simple script which has the instructions to assemble our Docker file. If I can relate this with a recipe, right? If I'm creating a dish, I need to have a recipe where I write my instructions step by step and I follow it. Similar is your Docker file to create your Docker image. What are we doing inside this, right? I'm making use of a base image. Docker image can inherit from other images, right? And I'm making use, the from is one instruction. We have different instructions and arguments what you pass to a Docker file. Of course, from is one of them, the base, which defines the base of my image, right? Atul was mentioning us that, in a container, we have everything we need. And this base image is what I am making use of, which is of Python 3.8 version, made of a slimmer tag. This particular base image has everything I need. Docker images can be inherited from other images. Instead of creating my own base image, I'm making use of an official Python image that already has the tools and packages what I need to run my Python application, right? It's already part of this particular image. And what I am creating is a folder called as app. This is going to, create a working directory for me inside my image. This is going to instruct Docker to use this path as the default location for all our next subsequent commands. The advantage of doing this is I do not have to type out all the full path, and I can use relative path based on my working directory. It's going to create a work directory called as /app, and we're going to copy the requirements.txt file what we have. So usually the first thing we do once we download a project written in Python is to install pip packages, right? This is to ensure that you have all your applications and has all of its dependencies installed, right? And before we could run the pip3 install, we need to get our requirements.txt file onto our image. And we are going to make use of the copy command to copy this from my Docker host onto my image file system. Right now, the requirement.txt file is on my Docker host. I'm copying that inside the image. When I copy that, it is going to be available under /app. And I'm going to install that, right? Making use of the requirements.txt file what we have. When I say run is the instruction which gets executed and gets added as another layer. Right? When I do pip install, it is when I'm going to run. At this point, it's going to look at that file, what is there inside the text, and it's going to execute that command. It's going to execute which command? pip3 install. Right? It's exactly similar to as if I was running pip3 install locally on my machine. But in this time, it's going to get executed and be part of my image. And I also have showed you the copy. I have a app.py program out there, which will be copied onto my image. I have used the relative path, dot meaning the current directory, will be copied onto the container's current directory, that is your /app. And cmd is what we invoke. It's a command that takes, when the container executes, right? When we run our image inside the container, what command should be invoked, what should be executed is what we specify in cmd. What we see on the screen right now, a few basic Docker file instructions. There are many other Docker file instructions we have, making use of which we can assemble our application. Just to reiterate, what have I done here? I'm making use of a Python as a base image because this base image has all the builders, tools, compilers, modules needed for me to run my Python application. Copying the requirements, installing what I need, copying my source code, and when the containers run, containers are built for a specific service or a specific application to run. And the containers run as long as your application inside that is running. And how do we decide what that application is you as a developer decide how do you invoke your application. And there's an instruction called CMD, what we have, and we're going to run this. Exact similar way of how I showed you 5 minutes back on my server. Let me come back, save this particular file and look
Yeah,
at.
hold on. If you don't mind, just hold on, guys, before we move forward. So a couple of things here. So what we are doing right now, there are 3 roles as a Kubernetes engineer. Yeah, leave it here. So there are 3 roles or 3 major role I see as or 3 or 4 major role. One is target for developers. And right now what we are saying is for, if you're coming from a development background, you are containerizing the application. You have a Java, .NET, Python, PHP, whatever you're doing. You don't need to know the programming or coding. But this is for developers who are containerizing the application, which means they were running earlier for a different platform, or they want to build an image so that they can run. That's one part. Second is the administrators who will be or ops guy who will not do this task. They will get an image and they will deploy the image, but they will be deploying the Kubernetes cluster or setting up the cluster and waiting for the code or an image to be received by the developer. And then the third role, which is an architect role, which will be, you should have an understanding of, okay, fine, you need to create an image, best practices, how do you build images should be light, and so on. Similarly, infrastructure build is there. You know how these being are done and as an architect level. So these are 3 layers. And next class we're going to talk about is certifications. We talk about 3 certifications. One is, on the third role is about security. So there are 3 certifications. One is for administrators, CKA. Second is CKAD, which is for developers. And then for architects, both are important, which is, third role is security, CKS, Certified Kubernetes Security. And then you as an architect should be doing all 3 if you're an architect. Yep, I hope that makes sense. So right now, you don't need to know Python. You don't need to know coding if you're not from a development background. I hope that makes sense, guys. Thanks. Over to you. How many are, let's continue here. I was about to ask question. So this is right now we have written a code which we are containerizing, and we are creating an image, and then we'll run that image to start the container. Over to you.
Thank you, Atul. Right now, the copy what we see here, the Python program what I showed you is going to be get copied from my local host onto my Docker image. I also mentioned to you the Docker file is a recipe, right? These are the steps which will be executed and assembled and create the image. Let's see how we can do that. I have the Docker file. I have the files I need. I have the program what I wanted. I have the Docker file. And by assembling the Docker image build command, I can build an image out of it. How am I going to do is I have whatever tag I want to say. I want to call this as my app, and maybe the repository name is my app or the image name is my app, and maybe I want to give it a tag as a hello. All right, and I give the current folder as the current context for my build program. It's going to look at the files available in the current directory, and it's going to read all the instructions from Docker file, and it's going to create an image for me. Let me hit the enter, and we see, the build process ran and it created the image for me, right? There were a few things already in the build cache. It did not take us much time. Very nice. I already have an image called as my app hello. Let me clear the screen and list that particular image. Docker image list, the name of the file, right? I already have the image locally available, which we just created 20 seconds ago. Very nice. How can I run this inside the container? We've got to make use of the Docker commands. And the only thing we need to run a container when you have an image is maybe a computer which has Docker installed. The way it runs on my system, it is going to run exactly on your system the same way. Why? Because the image is immutable and the image has everything it needs. Right now it needed some Python libraries, modules, everything that needs, it is already loaded as part of this particular image. I take this, run it in your computer, you have Docker installed, that's all you need. Let's see how we can do that. I say Docker container run. I want to run that in the background and in the interactive terminal mode if I want to connect to it. And I want to expose the port 80 maybe on my host, and this application is listening at port 5000. Do not worry if you do not know this. Just trying to show you how I can run this particular application. Right now when I hit enter, a container is created and it is already running. Let me quickly do Docker.
So hold on, guys. this is how simple it is now that the container is started and running, and it's the underlying operating system, everything, whatever you need, my application is now up and running. That's how quicker it is. Does it make sense? Now, if you see, does it make sense, guys? It started now. That's why I said earlier, I said it takes just few seconds to start. And now my Docker is running here.
I have a program container which is running. Let's go ahead and access this. Let me bring out my browser. And it's available at the port 80 for me. So I do my IP address and the port 80, and I see the page which we saw earlier, right? That's welcome to our demo on containers and Kubernetes. Right now, what we see here is come running inside my container, right? So to what we showed you right now was how we had the simple Python application made and run on our server. And I showed you how easy it is to Dockerize it with the help of Dockerfile, build it as an image, and run it wherever you want. What we did was the hello world, right? Replace that with your application. I just copied one program onto my image file system. If you have your complex application, all you would do is copy that, just run the compile, execute the executable. That's it. The way it is running on my machine, exactly same way it is going to run on your machine as well. Now,
just to add to Rohan's port, I can now pick up that image that he created. I can run it either on Windows, Linux, wherever, as long as I have a container runtime, which is Docker. I can run it on any place. I can take the same image and run it on under the Kubernetes hood, which will create using a pod, which you can create. So now I can run it anywhere I want, and that's simple how it is. Now, all the dependencies, everything, you will never have any library issues or dependency issues or anything, because everything is bundled in that image. Now, each container, these containers can be run either on the same host or multiple hosts. You decide. You can run any number of copies from there. Yep. Who to share the Docker image? Mridul is saying who to share a Docker image. You can put it into repository, which we'll see. You can put it into Docker. You can have a private registry. You can have it on cloud, and you decide where you're to show it. It's now kind of a code which you can take it anywhere where you want protected. Over to you. Let's complete, Rohan.
Yeah. Thank you, Atul. To just add to that particular question, right? So if you were the developer and you're deciding whom to share, you've got to share your source code with your testing team. And when they start testing, they say things not working the way it was working in your machine, right? So now when you give them the image, the testing team runs it. It is going to run exactly the way it ran in your machine. It is going to run the exact same way in their machine as well. That's one. Just wanted to add to your point, Atul, on there. Okay, so let's move on to one more demonstration. Is where right now what we saw right now was the application which we built from the scratch. What about the Docker Hub, what Atul was talking about? There are all the leading softwares out there available on Docker Hub. Let me take you to Docker Hub. Hub.docker.com is a place where we have a lot of our images available. Let me quickly go over to Docker Hub, and maybe you search for any popular image. Maybe I search for Jenkins, I search for Mongo. You look at it, you have official images available. So maybe let me search for Jenkins, and that's what we're going to make use of. Before I run Jenkins as a container, I'm going to take you to one more place. Bear with me. If I just do Jenkins and I go to the installation on Windows, right? This what you see is the Jenkins official documentation, official page, right? It talks about the prerequisite. It also talks about some software requirements. It tells I need to have a certain version of Java installed, and those maybe who have installed Jenkins on scratch understand the difficulty, right? If you do not have the exact Java runtime, it's going to throw you some errors. Not that easy to set things up. It calls it out, right? It tells you've got to have some Java requirements, you've got to have some Windows thing enabled, you've got to have some compatible browser, stuff like that, right? Now, to set this up on my machine, maybe tops, I might need maybe say 30 minutes just to install, download the Java, set things up, reboot my Windows, whatever I need to do, right? I'm going to show you how easy it is just to download and run that as a container. Let me go back to Docker Hub. It talks about Jenkins as an official image. It tells you, you can run your Jenkins, which is your continuous integration and delivery server. And it also tells you how you can run this. Just make use of this particular container image, what I have out there, and that's it you need. Let's do that. Let me quickly bring out my terminal.
this is basically earlier part of a developer, and this is now for ops guy or the administrator who will be now got the image. The image might be in a Docker hub. It could be locally on your personal repository, or it could be on a cloud like AWS, Azure, Google, and you configure Docker to run and say where to run these or pick these images from, or you tell Kubernetes where to pick these images from on the CI/CD tool, where to pick these images from. We'll cover that. So this is what now deployer will do or ops guy will do. Over to you.
Thank you. Right now, let me just copy the command from the Docker Hub itself. It says just to run Jenkins in a container. We are doing the command called as Docker. I'm telling Docker the CLI container run. I want to name my container. I'm naming it as my Jenkins. There are a couple of options what we specify. Daemonized or detached interactive terminal. I want to expose a port. There are 2 ports on which Jenkins run, 8080 and 5000. I'm making use of a volume. I'm going to skip through that. The point I wanted to show you is I'm making use of the image. The default what Docker looks for is the Docker Hub, the place which we were looking at a few seconds ago. I'm going to make use of the Jenkins official image which is out there. I don't have to do anything, just make use of that particular image and run. Let me hit enter and we see the container is created and the ID is printed here. Now, if you didn't have the image locally, maybe based on your internet speed, this would have taken you a minute or so to download the image. In the interest of time, I had already downloaded that image. The image was available locally on my machine. Right now, this Jenkins is running inside my container. If I quickly do docker container ls, list me the running containers, I have this Jenkins running. All right, let's go and access that. It's running at the port 8080 and it says, hey, you've got to make use of this. You've got to unlock, enter the official, the initial password. Okay, let me quickly grab that for you from here itself. If I do docker container logs, bear with me for just 30 seconds. It's going to tell me the initial password. Mind you, this Jenkins, what we're seeing right now, what we're accessing, is running inside the container. I did not have to install Java. I did not have to do anything. It took me, let me install some plugins. In the interest of time, I will say none. Move forward. I will continue as an admin and I will start using as Jenkins. You see right now, I have the Jenkins server up and running. Maybe it took me what, 40 seconds? Not even 40 seconds, right? I had the image available and container came back in like a second and I have the Jenkins up and running. Let me show you, is it the real Jenkins what we have? Why not? Can I modify certain things? I want to just change the password, what the initial admin password was. Can I create a job? Why not? Let me quickly create a job. Some dummy job here. The point is just to show you that, this Jenkins what we downloaded is just going to work. Execute a shell. I'm just going to execute a ls command, save. Not going to run the job anyway. Just wanted to show you that a job is being created. Right now, what we have, the Jenkins server was set up in less than a minute and it's continued to run as a container. Things fail, the container goes away. I don't have to worry because what I did when I ran the container was I ran it as a volume. It's going to save that information. Anytime I rerun that, I have all my jobs saved up for me, right? Over to you, Atul. That was the simple demonstration on how to create your own application, Dockerize it, and also make use of some official image out there and run it as a container.
Brilliant, brilliant, guys. This is how simple it was. First, we saw a simple program to create a container application from a developer point of view. From an administrator point of view, how to deploy or how to start container, we just simply, otherwise it would have taken maybe easily a couple of hours to download all the prerequisite software, operating system, etc., and then install Jenkins and run it. Now it takes few minutes or less than couple of minutes to install Jenkins and ready and up and running. Same thing you can do with the databases or any other custom application you might be running, or whatever application is there. If there's an image, you can start it within minutes. That's what our companies doing these days. They don't take a lot of time. Just start and run your applications. Was it making sense? Is it making sense, guys? And if you to rate this demo and the session so far, and I'm going to tell you about